Looking at the problem right away, it asks you to choose the organ that shows the highest attenuation of the ultrasound beam among human tissues. The correct answer can be considered as option D. Yes, since air is contained within lung tissue, there is significant attenuation of ultrasound in the image. Next, let's look at problem number 42 below. Looking at the problem, it asks you to select the tissue with the slowest propagation speed. Let's write down the propagation speeds next to each one. Option A is 1460 and blood is 1560. Muscle is about 1600 and the fastest bone is around 4000. Liver can be explained as 1555. For several values close to the standard value of 1540, you should memorize the numbers. Also, since bone, which has the fastest speed, has a distinct characteristic, you should remember its value as well. Since the question asked for the slowest value, you can choose the fat listed in option A. Let's move on and look at the next content. This problem can be seen as a simple memorization pattern. If you look at the question, it asks you to find the factor that is not related to the resistance value. Therefore, you also need to remember the factors that affect the resistance value. Options A, B, and C are factors that are directly related to the resistance value. The frequency mentioned in option D can be explained as a factor that is not related to the impedance here. So, understand the content through the question and try to organize it as a simple memorization pattern. Next, let's move on and look at question number 44. If you look at the question, it explains that during the process of creating an abdominal image, a normal incidence or perpendicular incidence has occurred. Next, it states that they have the same acoustic impedance value. This is the most important point. The fact that the acoustic impedance values are the same means there is no difference in resistance, so there will be no reflection, which can be understood in the same context. Given that, this question is asking what kind of change will occur between these two structures. As I just explained, for reflection to occur in ultrasound, there must be a difference in acoustic impedance. Only then can reflection take place. So these concepts form the foundation of ultrasound imaging. I will explain this part separately in more detail. If you think of an ultrasound device, let's assume this part is the probe. Let me briefly explain with a diagram, assuming there is a liver and a kidney. When the ultrasound beam is applied from this side, the acoustic impedance encountered on both sides is different. For example, let's assume that the acoustic impedance in the liver is about 30, and in this part it's about 10. In this case, the returning acoustic impedance values will differ between the liver and the kidney. The technique that receives these reflected signals and reconstructs them into images is what we call ultrasound imaging. So, the most fundamental prerequisite is that the reflected signals must be converted into images, and to do this, we create images by utilizing the differences in acoustic impedance that vary between tissues. This concept can be considered the most basic aspect of ultrasound. Based on this explanation, let's return to the main content. In the question, it is stated that there is no difference in acoustic impedance and that both are identical. And since the incidence is vertical, you can consider that all beams are transmitted through, resulting in a transmission situation. In this kind of situation, the options related to reflection are largely irrelevant. In the case of identical acoustic impedance, everything is related to a situation where all beams are transmitted. Please make sure to remember this point. Once again, what you need to remember from this question is that for reflection to occur, there must be a difference in acoustic impedance. Let me emphasize this concept once more. Now let's move on and look at question number 45 below. If you look at the question, it asks about the reason for using coupling gel between the transducer and the skin. Simply put, it's asking why gel is used during an ultrasound examination. If we look for the correct answer, it would be option D. As I just explained, in ultrasound imaging, there is a difference in acoustic impedance, and we can say that ultrasound gel is applied to reduce the acoustic impedance difference between the transducer and the skin. In some textbooks, it is also described that gel is used to eliminate air pockets between the ultrasound waves or to remove spaces filled with air. This statement is also correct. However, if you are asked about the purpose of the gel in a physics problem or on a physics exam, while this explanation is also correct, it would be more appropriate to say that the gel is used to reduce the difference in acoustic impedance, as this is more directly related to physics. So it's not that eliminating air bubbles is incorrect, but rather you should remember that the point the exam is trying to test is closer to the statement in option D. Let's move on and look at question 46. This question covers very fundamental content. Questions asking about units are always included in at least one or two problems. Since the unit for resistance is quite unique, you can remember it through this type of question. You should select answer choice B as the correct answer. Let's look at question 47 right below. This question also follows a simple pattern. You just need to pay attention to the related keywords. The fact that absorption has occurred means that acoustic energy has been converted into heat, so you can think of it as following the same pattern. You should note through this question that the keywords absorption and heat are related. Now let's look at question 48 below. At first glance, this question may seem a bit difficult. In reality, it's actually a very simple pattern. It says that 1% of the transmitted portion appears between the two structures. It is written that the transmitted portion is 1%, so this question is asking how much of the portion is reflected. If the total is 101% is transmitted, then the remaining 99% must have been reflected. So the correct answer is choice B. Now let's move on and look at question 49. Question 49 is also a frequently appearing pattern. You need to remember the term Rayleigh scattering. When this kind of term appears, there is only one keyword associated with it. Since things like red blood cells, or RBC for short as shown in option C, are related, if you see Rayleigh scattering, you should choose the keyword related to red blood cells. Rather than trying to understand it in detail, I would say that applying a simple memorization pattern is more efficient. Let's move on and look at question number 50. If you look at the question, an image is provided. This question asks about the mechanism that caused the shadowing seen in the image. The image is described as showing the fetal head. First, let's take a look at the picture. Although it's not shown in detail in this photo, you can expect to observe a shadow falling darkly at the edge of this area. This kind of shadowing appears at the edge of the fetal head. In fact, this is the most frequently tested pattern among all the images. There is a shape called overhead, and questions about the mechanism by which shadowing occurs at both ends are always included in one or two problems. The correct answer can be found in this number. The mechanism behind this pattern can be explained as being caused by refraction.